Hello, I'm called Gariss, and this program is Cosmology. Sheer madness, but I thought maybe this morning, since it's a good morning for madness, I would try to summarize what has actually happened in this change from one cosmology to another. Now, I'm probably going to fall on my face or my buttocks, depending upon which direction I'm leaning at the moment. But let's see if we can do this. Share it with me. Explore with me. And again, remember my style for the new listener, because I sometimes have to explain this in letter or Jeanette over the air. This is always spontaneous. It's as though we were gathered together in front of the fireplace out in the meditation shack and just conversing. This is a flow of consciousness, not a lecture. In other words, I'm not that much interested in linearly depicting these events. But this is a flow of consciousness more in terms of James Joyce, Ulysses, or Virginia Woolf's works. Or if you return to the meditative tradition, perhaps more in the order of Marcus Aurelius, the Stoic, the Roman emperor. He had a beautiful saying. He said, as Marcus Aurelius, I am a citizen of Rome, but as a human being, I'm a citizen of the universe. I like that. But this approach, in other words, is more meditation in the traditional Christian sense, where you take an idea, in this case cosmologies, and then you sort of allow yourself to float around that idea, the emerging thoughts, images that arise from that single idea. It might be compared to Boethius, the great philosopher who died in prison or was executed by a Roman emperor. His collection of poetry, of musings, really, reflections. Who was the Jeanette? Who was the author of the History of Western Philosophy?
Bertrand Russell.
Beg pardon?
Bertrand Russell.
Bertrand Russell, yes. Bertrand Russell said of Boethius that there was probably no man 200 years before he lived and 800 years after he died that was so free of superstition as Boethius. That's quite a compliment. So, again, this approach is more in that tradition, or just stream of consciousness, if you want to put it that way. So, bear with me as we explore this transformation of the scientific worldview through 20th century physics and cosmology. The thing I think that one always has to realize is science has its mythology as well as religions. And by mythology, by myth, I don't mean the lie or just imaginings, but the unifying vision. Myth, as Joseph Campbell speaks of it, the unifying vision, the vision that allows a country or a culture to understand itself and its relationship to the totality in as far as it knew. And myths and mythology are really the science of their times. For the Sumerians' concept of the nature of gods and the movement of planets through the sky was based upon their latest scientific evidence. That is, they saw movement through the sky, movement of planets through the sky, and this laid the foundation for astrology. It also laid the foundation for the form of the city-state, which we still inherit today, and perhaps in the future that will change. But we still owe the Sumerians the concentration points of our culture, the city. So, in the Copernicus-Newtonian universe, it had gods too. The absolute gods of space, time, and object and determinism, which they felt was absolutely real, and these gods had as much power as any of the ancient Greek or Norse gods. But it's commonplace that the immensities of space and time, which confront us in the universe, have been magnified, say since the time of Copernicus, or perhaps more since the time of Galileo, by orders of such magnitude that it simply overwhelms the imagination. That is, how much more we can see with the use of the telescope and the microscope. And it's probably less appreciated than it really should be that 20th century physics has brought about a transformation of our common sense view of the world. A transformation fundamentally more radical, really, than any mere multiplication. That is, increasing the size of the telescope lens to see deeper and deeper into space, or further and further into subatomic, or not into subatomic, but into the micro world. For the multiplication, no matter how by such magnitude, was still Euclidean space and Newtonian time. It was still the space of the old geometry and the Newtonian linear time. And no matter how far we magnified through lens perception, nevertheless, it was very directly dependent upon our apprehension in space and time through our senses. We had the aid of instruments and the aid of clocks, telescopes, microscopes, all the other things. But it was still essentially our senses that were magnified. Now, this is not a naive duplication of sensory experience, and yet there was a priority, epistemological priority, if you wish, to the visual and the tactile. This was before the changes came about. Matter was still regarded in the Newtonian Copernicus world, or cosmos, but matter was still regarded as essentially impenetrable. It was solid. And particles of matter were always imagined to possess a certain bulk, and shape, position, which could vary with time. This is sort of if you want to give it a name, the corpuscular kinetic view of matter. Corpuscles, the ultimate particles, kinetic motion or movement. Now, It involved a modification of our immediate sense perception of matter, but it did not transcend our sensory imagination. There's a very famous quote from John Tyndall, I think it was 1870s, 72, I think, in which he was giving a satisfactory scientific description of a satisfactory scientific theory. And here's what he said. This was in 1872. Ask your imagination if it will accept it. And what was accepted involved some kind of mental picture or model located at an absolute three-dimensional space, a Euclid space, and an absolute time which Newton had long since established in the general scientific imagination as being that, quote, absolute true and mathematical time which of itself and from its own nature flows without relation to anything external. By another name, it is known as duration. End of quote. So, you see, time was absolute. Matter was absolute. Space was absolute. Underlying this view of matter, the corpuscle, the kinetic view of matter, are the ideas of absolute object, that there is an absolute or objective entity independent of observers and experiments. It existed out there. Also, another god of this pantheon was absolute determinism. That the distribution of these objects change continuously according to certain laws of mechanics, Newtonian laws. Now, in its weaker form, this determinism is still accepted today, widely accepted today. It simply refers to the assumption of scientists that in nature certain events seem to be connected. And the presumption that there is some sort of mechanism, generative mechanism, which can make these interconnections intelligible. But in the stronger determinism, as it existed in the earlier days of the Newtonian universe, there was more of an iron law of necessity, a principle of determinism, meaning that everything that happens occurs of necessity, as if it were fixed in advance. Now, this notion, although it was probably amplified by Newton, nevertheless, like many other notions that we have that we think that are scientific, was really based in antiquity. Determinism, chance, chaos. These are the three companions that you will find in ancient Greece, or indeed in ancient China or ancient India. It's a question of karma. Does every event have its cause? Do events that happened in a past life determine how your life is going to be now? Or do you have to pay, in other words, for past debt, past karma? More strictly, in Orthodox Hinduism, what you did in a past life, determinism in other words, what you did in a past life would determine where you were in the scale of things, whether you were in a higher caste or a lower caste. So there was very definitely a sense of cause and effect. Even in Christianity, original sin, that which was done by Adam and Eve, affects our lives. So there is a very strong deterministic bias in all of that. But this kind of determinism, as expressed in early science, that there was a strong iron law of necessity, probably, as well as being influenced by Newton, probably also came out of the concept of predestination of the Protestants after they broke away from the Catholic Church. And the idea behind all of this is really sort of an ultra-transcendent creator who, after one creation in time, left his universe to follow its course controlled by unalterable laws. See, that was the basis of early science, of the Newtonian universe, as well as the basic idea in religion, or in Western religion. Well, this pantheon of absolute gods, space, time, object, determinism, was destroyed. It was almost a Gotterdammerung, which the golden prize of absolute intellectual ascendancy over nature's laws, which these gods have attempted to seize, were finally destroyed in the great conflammation. The new fires of the quantum and relativity theory, these were the fires that destroyed the ancient gods. Now, most of us, including physicists, still move in the old world. And there's sense in this, considering the scale of our sensory apparatus. We still have to walk across the street without getting hit by the car. And we still have to, most of us anyway, still have to follow the dictates of linear time, the clock. It wouldn't be much good if I decided I wanted to come on 10 minutes early or 1 hour late, because it suited my subjective time. So we still live in this world, even though these gods really have been eclipsed, and their world is gone beyond recall, and they'll never come back, any more than the Greek gods will come back, or any more than the crystalline spheres of the ancient Greek philosophers, Ptolemy. So what is the view today on space, time, object, and determinism? What's the new world view? What rose out of the ashes of these old gods? Now, within a very few decades, the development of quantum and relativity theory began to have an impact upon the philosophical worldview, upon the cosmological model, if you will. Unfortunately, it's practically had no effect at all upon theology. Absolute space and time has been relativized by Einstein, showing that all frameworks of reference are relative. And he unveiled this fascinating, intricate relation between space, time, and the speed of light, the velocity of light, light being the fastest signal that can be transmitted through the universe. And then moreover, in his later theory of relativity, general theory of relativity, the thinking of space-time as four-dimension, not just three-dimension, a four-dimensional continuum, and related through a new geometry, not the old geometry of the Greeks, but a new geometry, to gravitation. Now, up to now, gravitation has always been thought connected with mass, dependent upon mass, but mass in itself has changed in this new world worldview. Mass is shown to be interchangeable with energy. So you see, the absolutes are disappearing. It's very hard anymore to put your finger here and say, this is ultimate reality. What is ultimate reality? Mass that changes into energy? Gravitational relationship with mass, therefore with energy? Time considered as a dimension? So that from the ashes of absolute space and absolute time arose the phoenix bird, you remember, rising from its own ashes. The phoenix bird of a new, deep-seated relation between space, time, matter, energy. And furthermore, under this impact in quantum physics, the impact of the need to adopt wave-particle complementarity, that is, that light can either be a wave or a particle, depending upon the nature of the experiment. They complement each other. The yang-yin, the ancient yang-yin vision of reality. But this wave-particle complementarity for small particles and the acceptance of the Heisenberg principle of uncertainty. You remember that? And we'll go more into this in detail as we explore particles in future programs. But is that you really can't tell in the subatomic. There's no certainty. You can't tell if you know a particle's position, let's say electron's position, then you can't discover its, you don't know its momentum. If you know its momentum, you don't know its position. So that the idea of classical physics, of the objective observer, who rationally describes the properties of the world as they exist independently, this is no longer acceptable. Remember Wheeler, who says this is a participatory universe. Of course, what he was referring to is setting up experiments to determine the nature of particles, but the very setting up of the experiment determines something of the nature of that reality. Or Richard Schleicher has put it this way: we have learned that man cannot describe the physical world as if his own investigation had no effect upon it. The classical physicist who could sit, as it were, on one side of the translucent screen with his thoughts and experience, viewing the world he studied on the other, is now the impossible spectator. For much of physics, the dividing screen is lost, and it cannot be replaced. Especially on the level of individual atomic processes, the scientist finds now that he in fact has a role in the creation of the world that he is describing. It is not that his emotions bias his results, but rather that his act of observation participates in forming the natural world. See, these are radical. This is a radical view when you think of the old Newtonian world. Remember what? Time runs out there. It has nothing to do. It's merely duration. Space is absolute. All of that's gone by. So the result is there are alternate potentialities in a system at any moment, and only some are realized in their subsequent encounters with the observer. You see, we've shattered totally this concept of absolute, except in religion, of course. They haven't caught up with it. Oh, there's process theology that's going on now based upon Whitehead. It's very interesting. But human beings can no longer describe the physical world as if their own investigations had no effect upon it. Again, especially at the level of the individual atomic process. Niels Bohr, the great Copenhagen scientist who really developed the modern approach to quantum physics, said it very well. We are both onlookers and actors in the great drama of existence. Now, the other major feature of the worldview that is developing now. Well, let's first of all refer to the old world, the absolute determinism and its corollary predictability. Today, this is no longer tenable. You can no longer hold on to determinism except perhaps in religious terms, and that, of course, they are existing in another universe. But it's no longer tenable. It's realized now that there is no logical necessity in believing that determinism, in the sense that, say, if state A is followed by state B, the same state A will always be followed by B in the finest detail, that there will be that iron law of necessity. It appears much more to be merely a postulation, an assumption, an adjunction to look for causes, to continue to look for causes. We now know that there are certain systems at a subatomic level which will never be able to say precisely what new state will emerge or will be consequent or will follow any particular state at any earlier instant. And I might add here too that this is the insight that we're gathering in states of consciousness. The states of consciousness have undergone tremendous, our view of states of consciousness have undergone tremendous changes, say, since the late 60s. We are breaking away from the old behaviorist, which is, after all, a kind of deterministic, you see, a sort of mechanistic view of the universe, which physics has thrown out, but which psychology still clings to. Psychology, sister to religion's handmaiden. As already mentioned, we know only the probability of a number of alternative states that might succeed the initial one. This is true in physics, but it's also true in states of consciousness. However, I think this isn't to deny causality. A man named Born, B-O-R-N, not to be confused with Bohr, claims that the quantum theory does not deny causality, although it does deny absolute determinism. Causality, he says, is that one physical situation depends upon the other, and causal research means the discovery of such dependence. Well, this is still true in quantum physics, though the objects of observation for which a dependence is claimed are different. They are probabilities, not single events themselves. The day of predicting single events in the subatomic world are gone forever. But equally, this is true in biological science, if you just stop to think for a moment. The complexity of biological systems. Can you really predict? The variability, which is what biological scientists come up against, or experimental biologists come up against, really means that most biological laws are statistical, just the same as in subatomic. Only average properties can be related. The concept of evolution, for example, applies only to populations of organisms, not to individual organisms. So that when you deal in the biological realms, you deal with it very much in the same manner as you deal in the subatomic universe with particles. Now, The 20th century development in physics, the new statistical awareness and understanding of the complexities of many of the natural phenomena have then drastically modified the old determinism and predictability without denying causality. So this implies a kind of openness in the texture of natural events, which was really perhaps never appreciated before this revolution in physics, that you could have this openness, that there could be a variety of things. There could be surprise in the universe. Now, probably the most distinctive feature of the modern scientific worldview, and this comes from different sciences, quite different sciences, and that is the process of evolution. Historically, it was the geologists who first discovered time as a kind of matrix of intelligible change in the 18th century. And then this was followed by the biologist in the 19th century, and of course today by the molecular biologist. And then the astrophysicists and the astronomers have provided the evidence on which to base a scientific cosmology, the account of evolution in time of the universe, of its galaxies, the solar system, and of the planet Earth. Now, these insights of cosmology have been coupled with speculation and knowledge about the origin and evolution of life on Earth. And together, this begins to yield a perspective of beauty, of interrelatedness, of such an all-embracing scope that it dazzles the mind, it heightens sensibility. It creates the awe of religions, the wonder of our interrelatedness to everything, and how it all follows a patterning, evolving. The cosmologists, the astrophysicists have shown that, say, from a time of the order of 10 billion to 18 billion, depending upon the individual. Years ago, there was a primeval, unimaginable condensed mass of fundamental particles that were transformed and at the same time expanding into the present observable universe, in which these particles have undergone, again, various transformations, condensations, to give rise to the matter that we now observe through our telescopes and spectroscopes in the universe. Then the nuclear physicist and the chemist have unraveled how in the nuclear furnace of some very hot stars, ancient stars, heavy elements were formed. And this evidence, combined with that of astronomers and geophysicists, have shown how that through supernova explosions, these heavy elements were distributed to second and third generation stars, planets such as our own. So Earth came into existence. The chemists have demonstrated how on the surface of this planet, as it cooled, the simpler molecules, both large and small, formed the building blocks of living systems. This arising entirely through purely chemical means, processes. The molecular biologists, the biochemists, the geneticists have given us the basis for inferring how from this primeval soup might have emerged complex organisms of matter which could become self-reproducing. The biologists have elaborated how, once given these primeval living forms, the processes of natural selection operating upon genetic mutations, that is, of changes in the information and instruction transmitted from one generation to another, could have given rise to the vast variety of living forms that have existed, and many which still do exist on the surface of this earth. And the psychologist and the linguist and the anthropologist are beginning to tell us how the emergent, self-conscious human being acquired language and society and culture, a culture which has engendered a desire to ask the questions that we're asking this morning. So, this evolution, as perceived by so many different disciplines, reveals a continuous law-like, that is, subjected seemingly to laws, law-like nexus or reference, connection. You can best describe it, as it's been traditionally described, as an undivided whole, a seamless robe. Nature, including human nature, is not a heap of fragments, but it's a unified field of interrelations or interrelationships in which nothing can be considered apart from anything else. The unity of all things is with us always, even if it continues to remain just behind, below, or beyond the limits of our perception. The seamless character of this web, which has been spun on the loom of time, is continuous again from beginning to end. At no point does the modern natural scientist have to invoke any non-natural causes to explain what he observes or infers from the past. Another outstanding feature of this process of evolution, and a very important aspect, is its emergent qualities. Let me quote from a scientist, Denbigh, D-E-N-B-I-G-H, a well-known a student of the thermodynamics. And he describes it in this fashion. What can be said with a considerable degree of confidence is that cosmic evolution has been attended to by a great increase in the richness and the diversity of forms. No doubt such an increase would be difficult to define in precise scientific terms, but even so, the evolutionary sequence which has been outlined is consistent with the idea that diversity has made its appearance out of homogeneity, out of homogeneous beginnings, and that many of the significant events in the sequence may have occurred non-deterministically in many of the details. So that as, end of quote, so that as matter has coalesced into more and more complex forms, new and very different kinds of behavior and properties have come into existence. Now, these properties, this behavior, could never be determined in any of the beginning stages. How could you ever determine that water, for example, would come out of oxygen and hydrogen? How could you ever determine that earth could come out of a mixture of the elements of which it is composed? So, different properties do emerge. In other words, properties that are not seen at the beginning of things, as the Chinese Taoists would say, in the seed stage. And this is very important. This is perhaps the weakness of comparing, as is the fashion these days, principles of quantum mechanics or quantum physics or subatomic particles to consciousness. This is again a reductionistic attitude. You're not taking into account this very quality that I'm talking about. Emergence, the emergent character of evolution, that new and different things, different behaviors and different properties arise out of comparatively simple beginnings. Now, the extent to which these new emergent features can be explained or reduced to descriptions, and always when you try to reduce to descriptions, you tend to bring them down to less complex levels. This is a question that you always have to return to. But the nature of the development, this emergent quality, has given new meaning to time, time being the carrier of innovative change. Now just think of my old description of time in the Newtonian universe. It was mere duration. It was something that was by itself. See, that has changed drastically. We now think of time as a carrier of innovative change, in contrast to time that flowed by without relation to anything external, as envisioned in the Copernicus-Newtonian world. So let's just make a quick comparison then between classical and contemporary scientific worldviews to sort of summarize what we've said. Looking back, we now see that in the beginning of the 20th century, and this is all so recent, isn't it? The beginning of the 20th century, it initiated a series of fundamental changes in the scientific perspective of the world. And some of those changes might be summarized, say, the classical then and the that of today. Then nature, before the 20th century, was regarded as simple in structure, basically substantial, reducible to a pattern of combination of relatively few entities. You had the atoms. Of course, atoms went back to the Greek times, didn't it? Concept. Now we know it is an enormously complex, multitudinous variety, basically relational, consisting of a hierarchy of levels of organization, which cannot always be reduced, and which span from the baffling micro world of the subatomic to the macro world, which includes the biosphere and within the range of our sense perceptions, to the mega world of intergalactic distances, of cosmological processes unfolding over billions of years, and of the gravitational field of the black holes. Then, in the old classical physics, we saw the natural world was regarded as a mechanical, determined, predictable, from any given state by means of laws of all-embracing scope. Now the world is regarded rather as a scene of interplay, of chance, and statistical, as well as causal, uniformity, in which there is indeterminacy at the micro level and unpredictability because of the complexity of causal changes at the macro level, especially that of the biological. Then, in spite of Darwinism, the natural world was still largely regarded as static in form, exhibiting little novelty, essentially complete, unchanging, closed. Now it is discovered to be dynamic, always in process. The old description of Heraclitus, the old Greek philosopher, you can never step in the same river twice. A nexus of evolving forms, essentially incomplete, inexhaustible in its potential for change, and open to the future. Then the world, in the classical physics, the world seemed to be decomposable into readily intelligible subunits, to have accessible foundations. Now, a sense of mystery, a real sense of mystery, at the quality of the known and the quantity of the unknown. This has been engendered by the depths of reality encountered at the edges of experimental and theoretical inquiry, where there seems to be no ground level of simplicity, no accessible bedrock on which to build the structure of the universe. Physicists have become aware of the infinite complexity that can be fitted into a finite kingdom or a finite domain, both with respect to the subatomic domain of space and the new entities discovered there within, the quarks, others, and to the unimaginably small but finite intervals of time immediately on our side of that Big Bang, that current myth about how the things began, that singularity in cosmic history from which the present universe expanded roughly some 10 to 18 billion years ago. You see, these contrasts are considerable in an amazingly short time. No wonder some of us rush back to fundamentalistic concepts, clinging to old gods, because there's nothing much to cling to here, is there? No rock to hold on, no rock of ages. Look deep enough in the rock and it's just swirling energy. Somehow it seems safer if we could just resurrect some of the old gods and worship them. But it can't be done. Even theology has to recognize this. Even if they are dealing in the realm of gods, these gods are going to have some relation to the universe as we know it. This is, of course, the great quandary of the modern theology. But all of these contrasts are really changes between the scientific perspective of the world of then, of 1900, and the now, the second half of the 20th century. We have experienced, we have witnessed an unparalleled expansion of human consciousness of the world. And this expansion has, curiously, and I think rather significantly, been coupled with a new awareness of the fragility of our own knowledge, of human knowledge, as we know more and more about consciousness. The realization on one hand of the ambiguity of our knowledge, and on the other hand, the loss of that objective spectator through the uncertainty principle, through relativity. we can't just say this is the way things are. This may be the way things are. The uncertainty principle, probability. And then our recognition as we know more about the brain and its relationship to consciousness, our recognition of the physical limitations which constitute horizons beyond which we're unable really to ever explore the universe. Mystery returns. We have expanded our awareness on many different levels: radio waves, gamma, X-rays, expanded our spectrum of vision. But I think scientists are beginning to realize, perhaps as religious men have always known, or people, intuitively, there are parts of the universe are always, it seems, causally out of contact with some other parts at any given time or at any given point in space-time. Think of the black holes. It's out of contact, causally, with the universe as you transcend space-time, as you go through the singularity, if you go through it. Does it indeed lead to other universes? Or to other parts of our universe? There are many phenomena in our universe which seem out of touch causally with the rest of the universe. And then there are limitations at the other end of the spatial scale, which ensure that there is a lower limit, micro limit. We're far from approaching yet to the smallest distance we can discriminate. But there is a limit, the wavelength of any energized investigating particle. So it's in such a context that Sir Bernard Lovell, the British astronomer, the Greenwich Observatory, talks about being in the center of immensities. Or Weishaupt, the scientist, reminds us that our knowledge is an island in an infinite ocean of the unknown. So that perhaps more than anything else, in this new dawn of vision, the new Einsteinian vision, mystery has returned. We cannot know it all. Also, I think, what has resulted in these new visions, the intellectual beauty, the coherence, the all-embracing scope of the scientific perspective on the universe, that the physical, let alone the biological sciences, have allowed us in the last few decades to see, to sense. It provokes, again, a response of awe and wonder, which can only be equated with a religious experience. Our relationship to the totality, to the whole. But most importantly, out of all of this, is a new vision of a cognizing, a self-cognizing universe. A knowing, a self-knowing universe. The human brain, which generates this inquiring activity that we have been going through, in itself is made up of the same matter, energy, and space-time as the world it is investigating. And it itself has evolved a particular form of organization of that world stuff. So sometimes we might wander along with Darwin, quote, "But then arises the doubt, can the mind of man, which has, as I fully believe, been developed from a mind as low as that possessed by the lowest animals, can that mind be trusted when it draws such a grand conclusion?" End of quote. Well, it didn't exhibit Darwin. It didn't inhibit Darwin. It hasn't inhibited anybody else from seeking evidence of the grand conclusion. Our unity with the rest of the biological world hardly needs emphasizing these days, when we hopefully are beginning to awaken to our ecological concerns. And yet, even the most experienced molecular biologist may find his own imagination quickened by the extraordinary unity of the biochemical, metabolic mechanisms which we share with all other organisms, as lowly as the bacteria, and by the common genetic code which translates the genetic information. Oceans, we would have, for example, no iron to carry the oxygen, hemoglobin of our bloodstream, and so maintain our brain in an active state to communicate with one another. Indeed, our dependence and our involvement in the cosmic processes can be pushed back even further. The value of the fundamental constants, that is, the velocity of light, the gravitational constant, the electronic charge, the mass of the proton, determines the kind of physical world in which we live and are the basis of the physicists' calculations. Now, if, for example, the proton-proton interaction were only slightly different than all the proton of the world, of the universe, which were the raw material of heavy atoms in the nuclear furnace, would have turned into more inert helium in the earlier stages of the expansion of the galaxies. As Bernard Lovell put it, no galaxies, no stars, no life would have emerged. It would have been a universe forever unknowable by living creatures. The existence of a remarkable and intimate relationship between man, the fundamental constants of nature, and the initial moments of space and time seem to have been an inescapable condition of our presence here. End of quote. Or Wheeler, whom I quote so often, once said, "No theory of physics that deals only with physics will ever explain physics." I believe that as we go on trying to understand the universe, we are at the same time trying to understand ourselves. Only as we recognize that tie will we be able to make headway into some of the most difficult issues that confront us. Man, the start of the analysis, man at the end of the analysis, because the physical world is in some deep sense tied to human beings. End of quote. Just another way of saying participatory universe. So, the material units of the universe, the subatomic particles, the atoms and molecules, they are the fundamental entities constituted in their matter, energy, space-time relationships. And so they have built in, as it were, the potentiality of becoming organized into that special complex system which we call living. And in particular, this matter, energy, space-time relationship has evolved into the system of the human brain and the human body, which displays conscious activity. in us, at least in this space and time, this Earth, the stuff of the universe has become cognizing, self-cognizing, knowing, self-knowing. How this potentiality has become actualized in living forms, and the role of chance in all of this, of course, is very important, one of the most important questions that arise. But let's just for a moment consider another view of this intimacy of our relation with the nature of the universe. Once long entertained is the possibility, of course, that conscious life is elsewhere in this universe. But one of the new principles that have emerged, which illuminate our relationship to the universe, is the one I've talked about before, the anthropic principle. Anthro, like anthropology, the study of man, the man principle. Unfortunately, that was, I prefer the human being principle, but I don't know the word. It's called anthropic anyway. It was, this principle was first enunciated by a man called Carter. And curiously enough, it came from the most unlikely source. What he was attempting to do was to make intelligent to himself certain large number coincidences which have often been noted. And I don't want to get too much into this because I'm afraid that you have to spend a little time on this to make it understandable. But there are certain very large numbers in the universe which seem to be the same. Now, this is coincidence. They call it large number coincidence. But it's still a puzzlement. As a matter of fact, I was just trying to think of the physicist who lives in Florida, one of the old comrades of Einstein, the gentleman who developed antimatter. What was his name? Still alive. But anyway, he has proposed a alternative model of the universe based upon the coincidence of the large numbers. Now, I'll just give you one example, and I won't go into it because that's another whole trip in itself. But say the equality to within a few powers of 10 between the fractional expansion rate of the universe, this was discovered by Hubble, and the reciprocal of the number of baryons, those are heavy particle elements, in most stars, from the red giants to the white dwarfs. Now, why there should be a relationship between those numbers, no one knows. It must be coincidence. But there are equally other large number coincidences which are equally puzzling, such as Eddington's relation, the number of particles in the visible universe is the inverse square of the gravitational coupling constant. And I won't again get into that. But out of the study of this coincidence of large numbers, Carter proposed that, or argued even, that these and some other large number coincidences can be seen to be consistent with the current physics and cosmology if one evokes the anthropic principle. And that simply means that what we expect to observe must be restricted to the conditions necessary for our presence as observers. The universe is the way it is because we are here to observe it. Now, as I've said before, this is such an important principle. If you have felt sometimes rather puny and ineffectual and wonder perhaps in moments just before falling asleep whether the human race will ever survive and all of these things, or remembering the old 19th century dictum that perhaps we are the sport of gods, that all of this is by chance. Still being proposed today, incidentally, by people like Monod. But if you have ever felt yourself in this kind of cosmic depression, remember this anthropic principle. It's becoming more and more an important principle of the model, our present model of cosmology. What we expect to observe must be restricted to the conditions necessary for our presence to observe it. Now, in a weak form, this anthropic principle is, he's saying, which is sort of shocking in an Einstein universe, but sometimes it's good to be shocked, even in an Einstein universe. He's saying we must be prepared to take account of the fact that our location in the universe is necessarily privileged. Remember Einstein's insistence that everything happened in the universe at the same time. Well, we don't know. We haven't met other intelligent creatures in the universe yet. We assume that they're out there. All the principles of the universe seem to indicate they're out there. We haven't met them yet. But we do observe the universe. Our existence is the existence of observers of this universe of which we participate in. So that for life to evolve at all, the time for which the present universe has existed must be such that there are stars in it which have existed long enough for life to evolve upon them and to generate us, the observer. Otherwise, we wouldn't be here to observe the universe, and the universe wouldn't be here either. The very fact that the universe has existed as long as it has existed is, and this is what Wheeler means by a participatory universe, must imply that the nature of this universe is to be observed, to be participated in, or my way of saying it is the universe to become conscious of itself. This seems to be a necessary principle of this universe. If the life saver of the universe were much greater, say, than the life of a typical star, there'd be too few energy-producing stars for any chance of life surviving now. If it was much less, there would have been insufficient time for the formation of heavy atoms upon which our life depends. So, to summarize it, you can simply say, because we have evolved to observe it, our universe is a knowable one. And this, he suggests, places restrictions upon the kind of universe it would be out of, and get this concept, what he calls an ensemble of universes. An ensemble of universes. To summarize, we now observe that our looking out upon the great vistas of space, our peering back into the unimaginable distant time to the earliest stages of the formation of the universe, have somehow curiously turned full circle. And we find ourselves reflecting on our own presence in the universe and our cognitive roles as observers of the universe. So far from our presence in the universe being a sort of curious and inexorable surd, we find that we are remarkably and intimately related to it on the basis of this contemporary scientific evidence, which is indicative of a far greater degree of our total involvement with the universe than ever before imagined or dreamed of. Not even in the most glorious creation of the Middle Ages, our relationship to God, were we this intimately related to the universe. Although the Christians came as Hebrews, Jews, visualized the world as real and God as personal, in contrast to, say, the traditional Hindu or Buddhist concept that the universe is illusion and that God is impersonal. The Taoist concept would be the universe is real, but the creative principle evolves within the universe itself, which perhaps comes closest to our concept here. Now, just one other most important. Have I fallen on my face yet? One other most important insight, I think, to understand the modern cosmological model. That's the role of chance and the role of necessity. It's always, we generally speak of it in terms of free will and determinism. But when Carter refers to the ensemble of universes, this is another major speculation of modern cosmologists. Now, it's clear that when tracing back the history of this universe back to the point 10 to 18 billion years ago, when all of its mass was postulated, believed to have been concentrated into a relatively small space, there comes a point beyond which the law of physics as we know them cannot be applied. Now, this doesn't exclude the possibility that there is another side from us of the Big Bang, the hot Big Bang. And beyond this point, when the universe is squeezed through a knothole, and that other side of the Big Bang, all of the physical constants might be different. Of course, this is speculation, it's hazardous. But the nuclear electronic energy levels of the atoms of carbon, nitrogen, hydrogen, oxygen, phosphorus, on which living matter, as we know it, is so utterly dependent, might be totally different on the other side of that knothole, the other side of that singularity, that Big Bang. Indeed, these atoms, or even atoms as such, might not be even units of the universe on the other side of the condensed gravitational mass from which our present observable universe is expanded. So we have to visualize the possibility that our universe, the one which allows for the emergence of life, and so of us, is but one amongst a possibly infinite cycle of universes. And here I think you have to think of Wheeler and his concept of hyperspace. Now again, it's not just universes that preceded us and universes that may follow us, but as Wheeler suggests, universes that may lie on either side of us. Also, it's not just Wheeler, but it's the Penrose concept of the black hole, and how if one can use the singularity or that knothole in the black hole, that point which comes very close to the point of the mystics talk about going through that point. But Penrose suggests that there may be a whole chain of, a daisy chain of universes, and that going through the singularity may speculatively allow us to visit other universes. But Carter suggests that our universe would just be one in which the physical constants, gravity and so on, light, even physical laws, so that we could appear, life could appear in it, that we could argue about cosmology or even the existence of God. But again, a small change in any of these physical constants would result in an uninhabitable universe, at least as far as we know. And there could be various values of these constants. That there could be a run of universes in which a number, possibly the great majority, would not produce forms of living and eventually conscious beings. Some might, but beings beyond which we could not possibly imagine even the wildest science fiction. Because you're not dealing, you see, the chances are you're not dealing with constants at all, as we know it in this universe. Certainly, probably not the elements, perhaps not even the speed of light, perhaps not even the force of gravity. So that if beings emerged in such universes, they would be probably not recognized if we could ever contact them. They would not even be recognized as living creatures as we know it. Perhaps they would be more like the talking wind, or Fred Hoyle suggests in one of his stories, they would be cloud-like. That would be nice. Cloud-like, cloud with intelligences. So, it is possible, according to this. Now here I'm coming back to this rather scientific approach, as far as that may be. But it is possible that our present universe may be the only knowable universe, which is possible according to the physical laws that we know. And it might be the only one which could, by generating life, be observed at all from within itself. So that other universes, if they exist, might not know themselves. That's an interesting thought. Now, if you're going to take this seriously, and I think you almost have to, if you begin to think in the scale of cosmologies, then you have to look upon the role of chance. Now, remember Heisenberg's principle of uncertainty, which is really chance. Also, we know that so much of the genetic functioning is by chance. If you're going to look upon the role of chance as a means wherein all the potentialities of the universe are explored, then you have to extend both the time scale and even perhaps the ontological range over which chance is thought to operate. Chance must be regarded as not only operating to bring forth, to elicit the potentialities of matter, space, time over the spatial and temporal scales of our own universe, but chance you must also consider over the ensemble of possible universes, in which matter, energy, space, time might be replaced by new entities, consistent with other values of physical contents and acting, presumably, according to quite some different physical laws than those that we can determine in our own universe. Even so, this point is that over the extension of space-time, or whatever replaces it, the potentialities of the ensemble of universes, as well as this particular universe, are being or have been run through or explored. In other words, any number of possibilities have been explored, and therefore it is this which transforms chance, which seems so cold to us, that this universe rests upon chance in a subatomic world. But when you think of chance running through all the possible universes, then you begin to realize that chance and randomness is transformed into creative agents. For you have tried this, and you've tried this, and you have tried this, in this universe, and this universe, and this universe. In our universe, it happened to work that the universe could become aware of itself through us. In other universes, it might also work, but think of the number of universes in which it might not work. But you see, chance then is no longer random, but it is a creative agent operating through the ensemble of universes. So if you see chance in this context, you don't have to be daunted by the fact that the existence of life, indeed of our actual universe, is the result of its operation. And you no longer have to hold up chance as a kind of metaphysical principle, destructive of any significance or meaning to the universe, because its underlying structure is chance. For however long it may have taken, in the time scale of our universes, or no matter how many universes, which have preceded and might follow it, and which might be on either side of it, it's a fact that matter energy has, in space-time, in this universe, acquired the ability to adopt self-replicating living structures that have acquired self-consciousness and the ability to know that they exist, and are now even finding ways of discovering how they came to be. I think this is, it's limited. Let me just touch one more thing here before we end. This is why you can stress, when you think of chance operating as a creative agent, this is how you can stress the particularity of our universe, the particular quality. For in this universe there are certain kind of basic given features, and such as I've mentioned, space, energy, matter, which limit what can eventually be realized through its dynamics, its evolutionary process. Now, these limitations are necessary in the sense of being features of all worlds that may have existed or will do so. Yet for us, they constitute the givenness of our existence, its necessity in this sense. The givenness of these limitations, the physical constants that I talk about, appear to us to be a part of the necessity of our existence as boundary conditions which will never be otherwise. But you see, there's a limited kind of necessity, and they're not necessary in the sense of being features of all possible actual worlds in the light of foregoing speculations. That is, our existence is not necessary. That is contingent in the sense of not being present in all possible actual worlds whose evidence we can imagine. But it also, the same could be affirmed of any other self-conscious beings composed of particles of the kind that make up this universe. So, what we consider necessity is necessity only limited to the particulars of this universe. And what we consider to be random chance may be a creative agent that runs throughout all the possibilities of all universe. So it really comes down to this, essentially. We could not have free will without the boundaries, without the necessities. If gravity went off on a rampage doing whatever it wanted, we wouldn't be here to have free will. But you cannot have free will without chance, because otherwise everything is determined, has always been determined. So free will depends upon necessity, the constant of our laws. It also depends upon the chance underlying the universe. Thank you for sharing this time with me. Peace. you.